Has anyone ever told you there's another clever way to reuse old CDs like these? Today, I'm using just 2 unused discs to turn them into a proper DIY antenna. It might sound unlikely, but it really works. Alright, let me show you how it's done. First, I'll glue the 2 shiny sides of these CDs together using liquid glue, forming a single solid piece. The reason for doing this is to create a wider reflective surface. The metallic layer on the CDs can reflect electromagnetic waves, so when combined, they help concentrate and direct the signal more effectively toward the receiver, much like a small satellite dish. Next, I'll mount this signal dish onto a rotary tool to grind off the printed layer. Removing that coating helps expose a cleaner reflective surface. The smoother and more uniform the surface is, the better it can reflect and direct the signal toward the receiver. To connect the signal dish to the other key parts, I'll drill 2 holes at the marked positions on the CD. These holes will serve as mounting points, helping keep everything aligned and securely attached during assembly. This is an L-shaped angle bracket. I'll gently bend the longer side inward to make the next assembly step easier and ensure the parts fit together more smoothly. To improve the antenna signal reception, I'll add a smaller dish made from the bottom of a soda can. The base of the can has a curved, dome-like shape, which helps reflect and focus the signal more effectively toward the receiver. Here, I have 2 bolts, 2 nuts, and 2 metal washers. I'll use them as connecting hardware to link the key parts together, keeping everything firmly in place and properly aligned. Next, I've got a piece of copper wire stripped from a coaxial cable. which I'll shape into a spiral to act as a signal receiver for this antenna. The spiral structure is important because it increases the effective length of the wire within a compact space, allowing it to interact with more of the incoming electromagnetic waves and capture the signal more efficiently across a wider range. Copper is used because it has excellent electrical conductivity, meaning it can transfer the received signal with minimal loss, helping maintain a stronger and more stable connection. I'll secure this bent L-shaped bracket onto a small rectangular wooden board to form a stable structure that holds all the key components in place. The L bracket will act as the main support axis, while the wooden board serves as the base of the antenna, keeping everything steady during use. I'll prepare the signal receiver so it can be connected to the dish. This step ensures proper positioning and alignment, allowing the receiver to sit at the right spot where the reflected signals can be captured most effectively. This is a small metal electrical connector. It may look simple, but it plays an important role in linking the signal dish to the receiver element, helping maintain a stable connection and ensuring the signal can be transferred efficiently between the two parts. With this 2-core power cable that comes with a plug, I'll repurpose it to connect the antenna to the signal input. The insulated twin wires help carry the signal in a more stable way, while the outer casing provides protection and keeps the connection neat and secure. It might seem convenient to use this power outlet as a signal input between the antenna and the coaxial cable, but that approach isn't really appropriate. Power outlets are designed for electrical current, not for transmitting radio frequency signals. Using them this way can lead to signal loss and interference. For a proper setup, the antenna should be connected directly to the coaxial cable using the correct connectors to ensure the signal is transferred safely and efficiently to the TV. Alright, that wraps it up. Now I'll take this setup outside and test it right away to see how well it performs in real conditions. It's impressive that just a few seconds after connecting, the TV was already able to pick up a channel. But to know whether the signal is truly stable, we'll need to let it run for a while and keep an eye on it. And just like that, from a couple of forgotten CDs and a handful of simple parts, we've built something that actually works. Sometimes, the most interesting results don't come from expensive tools, but from a bit of curiosity and a willingness to try. If you got a few old things lying around, maybe it's time to look at them a little differently. Thanks for sticking around. See you in the next one.